These are the problems on the front side of the study guide for quarter 3, test 1 for Algebra A. And what I'm testing you on mainly is factoring polynomials. That's what you'll see in these first 6 problems. And on the first problem here, we are just asked to factor out the GCF, the greatest common factor. And so all you're going to do is look at each of the terms. Draw a line underneath each of the terms, look at them, and figure out what goes into each of these coefficients. So we look at the 2, look at the 10, and the 12, and they're all even numbers. Well, 2 is the number that goes into each even number, so I'm going to take out a 2 from each. And then go over to the variables, and I see that this one has 3 x's, this one has 2, and this one only has 1. So that means that I need to take out 1x. And that's common between each of these. Each of them has at least 1x. So once you take out that common factor, you're going to put it on the outside of a parenthesis. And draw the parenthesis as wide as the initial problem because we need 3 terms in here. Because what we're going to end up doing is reducing these fractions. So you're going to take out the common factor. Like here, for instance, on this first term, taking out these 2's. So those 2's cancel out. Taking out 1x here and taking 1x away from the top leaves me with 2x's. So I have x to the second power. That's all that's left of that first fraction. So I can put that in there. All right, well, we'll go ahead and bring down that plus sign and then reduce this. 2 goes into 10 5 times. And then x goes into 2x's. Well, we cancel out 1x on the top and the bottom, leaves us just with 1x left over. So there it is, just 5x. That's what we have. And look at the last term here. See, 2 goes into a negative 12 negative times, so it's going to be a minus sign there. 2 goes into 12 6 times, so we have that minus 6. And then we count up how many x's we have. Well, there's 1x here, which will cancel out 1x on the top, so that's it. Just the minus 6 is left. And that's our answer. And so the first problem, again, people get confused thinking, oh, I need to factor just 2 binomials, but no, it's just asking us to factor out the greatest common factor. Well, looking at the next problem, this is a 4-term polynomial. It's a 3rd degree one, because the highest exponent here is a 3. And what we're going to end up using is that factor by grouping method. So I'm testing to see if you understand that. And so all you're going to do is you're going to look at the first 2 terms and the last 2 terms. And from each set, take out the greatest common factor from each of these terms. So here we have just 3 x's. Here we have 2 x's. So all I can take out is x squared. It's the biggest number of x's that come out. So x squared goes on the outside. Draw a parenthesis around the width of the problem and think about what's left over here. So here we have a x squared. It takes out 2 of the x's here, so we're just left with 1x. So just an x. Over here, these 2 x's cancel out these 2 x's, so I'm left with a plus 3. Now we look at the next term. The next 2 terms here, and I look at the common factor. It looks like 5 is the only number that goes into those 2 numbers. So we take out a 5, draw parentheses, and then do some reducing. So this 5 here will cancel out this 5, leaving me just with x. This 5 goes into 15 3 times, so I'm left with an x plus 3. Now you're not done yet. You need to look for the common factor between these 2 terms. There's 1 term here and 1 term here. What's common? Well, they both share a common binomial. They share an x plus 3. And so we'll take out that common binomial of x plus 3, put that on the outside of a parenthesis, and then see what's left over once I cancel out those x plus 3's. See, these cancel out. I'm left with an x squared. And then over here, these x plus 3's cancel out, left with a plus 5. And there it is. Our 2 binomials is the way that 4-term polynomial ends up factoring. Well, the next 2 problems will have trinomials that have a plus sign for that last term. And whenever that last term is positive, that tells us that we have the same sign inside the binomials. So what that means is that the outer terms and the inner terms are adding together. And when we do that addition, we'll end up with a positive 7. Since positive 7x, in truth. And if that's the case, that tells us that both numbers, first numbers we know have to be x squared, because x and x are the only numbers that multiply to make x squared. But we also know there has to be a plus sign, because the outside terms, these terms right here, And the inside terms need to add to make 7x. So we think, okay, what two numbers multiply to make 12? So this is the number we're trying to come up with. These two numbers here will multiply to make 12, but when we check the outside terms and the inside terms, they will add to make 7x. Well, 4 and 3 multiply to make 12, and if you look at the inside terms here, I get 4x, outside I get 3x, and those numbers do add to make 7x. So you can always check your answer. You should know if you're doing it right in this test, because all you're doing is factoring. When you factor, you're coming up with two binomials that you can multiply back out and get the same answer. So x plus 4 and x plus 3. If you have the reverse order, it's the same exact answer. So we see a similar problem here. The difference is what they add to make. So, and multiply to make as well. We know that we have the same sign because they are multiplying to make a positive. So the outside inside terms this time add together to make a negative 10x. So that tells us something about the sign inside the two binomials. So when I draw those two binomials, I know my first terms are going to be x and x, the only numbers that make x squared. I know also the signs must both be negative. To multiply to make a positive 16 and to add the outside terms and the inside terms, they're going to end up adding together to make an 8x. And oh, actually, not just an 8x, but a negative 10x. Let's fix that. So they're adding together to make that negative 10x. Well, what numbers multiply to make 16, but they add to make 8? Or add to make 10? I was thinking of the answer. 8 and 2. 8 and 2 multiply to make 16, and those do add to make negative 10x. So you can see negative 8x, negative 2x. Those numbers do add to make that negative 10x. And so there it is, our answer, x minus 8 and an x minus 2. And again, if you had x minus 2 first and then the x minus 8, it's the same exact answer. Well, let's take a look at the next one. Next two problems, a little different, because you see this sign right here. It's not plus this time. It's a minus. So that means we have opposite signs. And when we have opposite signs, that means that we are going to end up subtracting the outer terms and inner terms. So we will take the difference of those two numbers, and when we do, we should get a positive 3x. So let's try it. So we're thinking of what numbers multiply to make 10. And we know x and x are the only numbers, again, that make the x squared, but we don't know the signs quite yet because they're opposite. So multiply to make 10. Well, we have different options, 5, 2. We also have 10 and 1. So we just try some, and we're checking those outside terms and inside terms. And so here we have inside of 5x, outside of 2x, and those do subtract to make 3x. So we got the right numbers. We just need to get the sign right. So we need a positive 5x to make a more positives than negatives to make a positive 5x. And we need a negative 2 here to make a negative 2x. And that will subtract to make a positive 3x. So it does end up working. So x plus 5 and a x minus 2. Well, let's take a look at the next one. Again, same sort of thing. I'm testing on to see if you understand what to do when we have opposite signs, knowing that the outside inside terms are going to subtract. We will take the difference. Opposite signs are needed in order to get a negative number when you multiply. So when we do this, first numbers that come to my mind for x squared are x and x. And to multiply to make 45, I think of 9 and 5. But there's other numbers like 3 and 15 as well. Well, we just have to try different combinations until we get those numbers where the difference will end up being 4, and the product is still 45. So let's check those outside terms. Here we have 5x. Inside, you're checking those make 9x. And when we do subtract, we do get a 4x, but we want a negative 4x. So that tells me this time I need more negatives than positives. So negative 9, positive 5. And that would be our answer. Well, we'll write that down, x minus 9 and x plus 5. Well, we'll do one more part, and that will give you the last two answers, and then we'll go on from there.